So here's phase 17. There's three parts to this problem. You're going to have three very similar parts to your practice. And I've already preemptively filled in some stuff just to make the video shorter. Okay, but we're going to do at least stick around for the three examples. If the last one you feel like, oh, I've got this, then make sure you at least look at the notes carefully and make sure you understand everything. So let R be the region bounded by y equals radical x, x equals 25, and the y-axis. Guys, the y-axis is also y equals 0. That's its equation. So part A, find the volume of the solid generated by revolving R around the x-axis, which is also y equals 0. So you find the region R by looking at where these things intersect. All right, so yeah, so you look at the intersection points. And then you think of those intersection points as like the corners of the region, or like the vertices of the region or something. And then you could see that's the region R. Okay, now we're first going to revolve it around the x-axis. So So to revolve this around the x-axis, and you don't always have to show the reflection part, guys, but I've noticed this helps people visualize it. So you just kind of like imagine reflecting this, the points like over on the other side. Because if it's like spinning and spinning and spinning, it's going to fill all the space. And so you are going to get like a symmetry. You're going to get symmetry. So since you have, wherever there's symmetry, there's like a reflection. So you can just go like that. All right. And so we're revolving around that right there. Okay, so that's spinning and spinning and spinning. Now I go to the axis of revolution. So this is the axis of revolution. So that's going to be the center of my circle. I know it's going to be a disc and not a washer because there is no empty space between the axis of symmetry or the axis of rotation and the region we are rotating. If there's no space, you're getting a disc and not a washer. I go to the end of the region, okay? And I'm right away going to label that I'm dealing with top minus bottom for that radius, okay? And then you can fill in the rest of the circle if you want. And guys, you don't even have to draw pictures for this. A lot of people are just going to see it in their head, like how this is going to work. But so you've got, oopsie. All right, so that's just one cross section. That's just one slice, and it's a disc. And imagine like infinitely many of them. All right, now I'm going to first find the area of that slice, and then I'm going to put it inside of an integral. Oh, and the slices are cut vertically. All right, so we're using everything in terms of x. And with this equation here is already in terms of x. So the area of a cross section in terms of x is pi r squared. And in this case, guys, to get the radius, you're going to do top minus bottom. So I'll just say here like top minus bottom squared. So the area in terms of x is pi, top minus bottom squared. This top point is on radical x. This bottom point is on y equals 0, so that's 0. So this is pi. Guys, this just ends up being x right in there. And then for the volume, oh, and we're going to do the first two with no calculator. All right, so for A and B, all right, we're going to do no math 9. We could use our calculator for the arithmetic, but we need practice doing the fundamental theorem of calculus, which is where you do the brackets and the antiderivative. Okay, so no math 9 for A and B, we will use it for C. So the volume is going to be the integral. The leftmost x value is 0, the rightmost x value is 25. Yep, and then you just put the area inside. So pi x squared dx. Now, no math 9 means brackets antiderivative inside. That's the fundamental theorem of calculus. Then you plug the top one in minus plugging the bottom one in. So for this antiderivative, I add 1 to 2 and divide by it. So that's going to be pi over 3x to the third. Okay, then I'm just trying to look. No, what did I do? Oh my gosh, that's only an x. Oh my gosh. All right, I'll correct this with white out, but that's bad. Pi over 2x squared, okay, is what that is. I don't know why I did that. Okay, then you plug 25 in, so this is pi over 2 25 squared minus, you plug 0 in, and that's just 0. So what you end up getting is that the volume is 625 pi over 2. All right, so that is the first answer to the first one. All right, now for the second one, we're going to find the volume of the solid generated by revolving R around the y-axis. All right, this time it's x equals 0. All right, so I did a whole nother picture. So we're going to revolve around the y-axis, which is x equals 0. All right, and I labeled everything already. Now, if we're revolving around this axis, we're going to get symmetry like on either side of it. So let me just kind of take this and, you know, it's not going to be great, but I'll do like some symmetry there. Okay, so we're going to be revolving. So the center of my cross section, which is going to be a washer, and I'll say why in a moment, is going to be on the axis of symmetry, okay, or the axis of rotation. The reason it's going to be a washer and not a disc is because there is empty space between the center of rotation and the region that we are rotating. So because there is this empty space, that's going to be, you know, I can even call that like, I don't know, I'll call that like right 1. And then you keep going to the end of the region, and I'll call that right 2. All right, and that's left. Right, the left is always the same, but for the inner radius, we'll have right 1 minus left, and then for the whole big radius, we'll have right 2 minus left. Or you can just call them both right, that's fine. All right, now let me just get a nice visual. So here's when the empty space is rotated, we get that. I want it to look sort of good. All right. Now, that's all empty in the middle. So it's this outer area. Okay, so there's the washer. All right, I'm going to do this without a calculator again. And then the last one I actually already have done. I'll just kind of like show it to you. All right, so the area, guys, this time the cross sections are being cut horizontally. All right, we're using right minus left for things. Now, the area of a washer is pi. Is pi, and then it's like big radius squared minus small radius squared. I already used R's. You know, usually this is like big R squared minus little r squared. I forgot how I did it in our formula, but okay, there's that. Big radius squared minus 100. All right, now, so in this case, for both my big and small radii, I need right minus left. Okay, so for this big one, right is 25, left is 0. So 25 minus 0 squared minus for this one, let's see if I did anything wrong. Okay, before. It's got to be right minus left squared again. Oh, but you know what I forgot to do? This has got to be in terms of y. So I've got to solve. So if you just square both sides there, you get that x is y squared. All right, so now this is in terms of y. So this right minus left is y squared minus 0. Y squared minus 0. All right, so that's the area. Now I'm going to plug it into an integral. So the volume is the integral from, now in terms of y, so lowest y to highest y. Look at the region. Lowest y is 0, highest y is 5. So 0 to 5, pi. 25 squared is 625 minus y to the 4th dy. Okay. Now, guys, a couple things. You could pull the pi out front. That's just a constant. Or you could distribute it. It's totally up to you. Maybe I will, maybe I'll distribute it. So 0 to 5, so 625 pi. If the pi is going to confuse you when you're doing antiderivatives, maybe you should pull it out front. Okay. Now, the fundamental theorem of calculus. The antiderivative of 625 pi is 625 pi y. Okay? So you just put, yeah, this is just a constant. The antiderivative of a constant is just, you know, the constant becomes a coefficient, and then you just have, you know, y or x if we were dealing with x. And then this one is minus pi over 5y to the 5th. Now I plug in 5. So this is 625 pi times 5 minus pi over 5, 5 to the 5th minus 0. Let me see what I got before. Oh yeah, I messed it up before. All right. So 625 times 5. This is 3125 minus 625. I forgot the pi. Oh my gosh. Pi. 625 pi. That's very important. Holy cow. And then is 2500 pi. Now, when you're doing these problems, guys, if you're not sure, you know, if you're not sure if you got the right answer, you could always plug, you know, Math 9 will give you a decimal, but you could like get this as a decimal and then plug this into Math 9 and see if you get the same decimal. Okay, that's a nice way. All right, final one, but I'm not even gonna, I'm just gonna show you. Okay, so this time, find the volume of the solid generated by revolving R around the line x equals 27. So you need to know that x equals some number is a vertical line, y equals some number is a horizontal line. So x equals 27 is this vertical line. We are revolving the same exact region that we had before around that. Okay, so I'll do like a reflection. I don't know, maybe that'll go there, maybe that'll go here. All right, so that looks not great. But so I did a reflection. Now, as far as the radius goes, like this is going to be the center of the radius. Oh shoot, now this time this is right. Darn it, so that's right. And there's two lefts. So now that's left 1. And that's like left 2. Okay. Yeah, so it depends on what side of the axis of symmetry the region is, what's going to be right and left, you know. Okay, yeah. So then I went like this. Let me just draw you a nice little picture. So that goes like that. And then this, not as great. Like that. So again, we have a washer because there was that space. I write down the formula for the washer. I plug in right minus left squared, right minus left squared. I've got it here, and I used math 9 this time. Okay.